Welcome to a lesson on the constant rate of change and linearity. In a previous lesson, we talked about a water tower, and we talked about the quantities that were not proportional, but they were related by a constant rate of change. Also, in another lesson that was done previously, we used this idea of the constant rate of change to help us fill out the values in the table, in addition to thinking about the changes in the value. So again, to recap, a constant rate of change means that two quantities are related by a constant rate of change if the changes in the quantities are proportional. To determine the constant rate of change, and in this lesson this will be abbreviated CROC or CROC. If two quantities are related by a constant rate of change, then a change in one quantity is always some number times as large as the change in another quantity, and this is using that constant multiple perspective of proportionality. Or the ratio of the changes in the two quantities is always constant, which is that constant ratio perspective of proportionality. When using the constant rate of change, the third perspective of proportionality, which is scaling, is normally not used, so we will not focus on it in this lesson. So again, recapping the idea of the constant multiple perspective of proportionality in the context of functions, we could think of that the change of output is some constant multiple times the change in input. And from the constant ratio perspective, that means the change in the output divided by the change in input is some constant ratio. Now this constant multiple and this constant ratio are the same number, so in fact when we refer to this number will be called the constant rate of change. And regardless of which way you determine that number, it will be the same, whether you use the constant multiple perspective or the constant ratio perspective. And the type of problem that you use will help you determine which one is an easier approach to use. So let's work through an example. So here we have a graph, and what we're looking at is, if we look at the independent quantity, it's the number of hours of work, and we use a variable h to define it, so that'll be the input. And we're looking at the amount of money made in dollars, and we'll use a variable d to define that, and we'll call that the output quantity. And so what the question is asking here is to explain the contextual meaning of the 2 points on the graph. So on this graph we have 12, 188, and we also have 26, 349. So let's think about this carefully. We know that that first coordinate has to do with the input value, and the second coordinate has to do with the output value. So the input is the number of hours worked, and the output is the amount of money made. So in the first case, the 12 must mean 12 hours. And what I mean by the first case is the first point. So the 12 must mean 12 hours, and the 188, which is part of that coordinate, must mean the amount of money made, which is in dollars. So in fact, 12, 188 means that if I work 12 hours, I am paid $188. Now we're going to also look at the second point, which is 26, 349. Now the first value of the coordinate has to do with the input, and that's the number of hours worked. And the second coordinate, which is 349, is the amount of money made in dollars. So if we put that idea together, that would mean that 26, 349 means that if I work 26 hours, I am paid $349. And that's what it means to explain the contextual meaning of the 2 points on a graph. Let's look at another thing. Determine the constant rate of change and explain the meaning of the value in the problem context. So in order to figure out the constant rate of change, well, first part is we need to see what the changes are. And so what we're going to do is look at the constant rate of change between 12, 188 and 26, 349. So let's begin. The first thing we would want to do is figure out the change of the input. And the inputs in this case would be from 12 to 26. So I'll use a little green line over here to represent that visually. And then if we're looking at the change, that means that the value of hours, the change in hours, increases by 14. So change from 12, if we change by 14, we get to 26. The change in hours is 14. Or you could simply think of it as 26 minus 12 gives you 14, which is a way to determine the change from 12 to 26. What we'll do next is now we're going to look at the change in output, because that's the other part that's important. And we are changing from 188 to 349. So you could think about 188 plus what is 349, or you could simply take 349 minus 188. So we're going to use a visualization, and when you do this, you get the change in D. The change in dollars made is 161, and so that means that if I earn another $161, I go from $188 to 349. So now what we want to do is now we have information to figure out the constant rate change, because we now know the changes in the quantity. And we also know that the changes in quantities is proportional. So we can use two approaches. We can use this constant multiple approach, which you see here, which is the change in output is equal to constant rate of change times the change in input. Or you can use the constant ratio perspective, which is the change in output divided by change in input is equal to the constant rate of change, the CROC. What we're going to do is just let's work on them parallel, and let's see which is an easier calculation to make. So change in D is some CROC times delta H in this context, because the D was our outputs, which represents the amount of money made, and H was our input, which represents the number of hours worked. So what we're doing now is we're looking at the change in D is equal to some constant rate of change times the change in H, and similarly the change in D over the change in H is equal to the CROC. Now in this case, our change in D is 161, and our change in H is 14. And so we're working on them simultaneously. It looks like using the ratio perspective will give us the answer pretty easily. So using a calculator, we find out the constant rate of change is 11.5. So that would tell us that if we were to work it using the constant multiple perspective, that 11.5 times 14 should give us 161, and we do find out that 11.5 is the correct number for the constant rate of change. So it doesn't matter which approach you use, you will end up with the same number, which is why it's called the constant rate of change. Okay, so we have 11.5 is the constant rate of change. That's the numerical answer. Okay, but we want to also explain or understand the meaning of the value in this problem context. So let's see what happens. Using it, perhaps it's more helpful to see it from a ratio perspective. So the change in D represents the change in the amount of money made in dollars, divided by the change in H, which represents the change in the number of hours worked, is equal to 11.5. So the units of constant rate of change are expressed in the form of output units per input unit. And the word per, and oftentimes in math, will mean a division statement. So actually, looking at this ratio perspective may help us also understand why we are going to define the units that we're about to do. So the output units in this case were measured in dollars, and the input quantity was measured in hours. So really if we're looking at this here, this is a change in dollars divided by a change in hours. So it's dollars, change in dollars, so we have dollars per hour would be, so that means the unit of constant rate of change are in the form dollars per hour. And so that means that the constant rate of change is 11.50 per hour, which means that for every hour I work, I earn 11.50. Now let's also take a look at the constant rate of change, because right now what we've done so far is we determined from going from 12,188 to 26,349, and we determined the constant rate of change. Well, what if you did it in the reverse? Perhaps you decide that you want to see what they would look like from a decrease perspective. Maybe it's a different number. Because we did have 2 points, let's see what would happen if we determine the constant rate of change from 26,349 to 12,188. So if doing this, to go from 26 down to 12 is a decrease of 14, which will be represented by negative 14. Delta H is equal to negative 14. And if we're looking at a decrease from 349 down to 188, that's a decrease of 161, which is represented by a change of negative 161. So change in D is negative 161. Okay, if we go through the same process, that says the change in D over the change in H using that constant ratio perspective proportionality is the constant rate of change. So negative 161 divided by negative 14 is the constant rate of change, which gives us 11.5. So that is exactly the same number that we arrived at using doing it in the other order. So that it doesn't matter which way you do it, you'll end up with the same constant rate of change, whether you go from 12,188 to 26,349, or from 26,349 down to 12,188, you get the same answer. And so the constant rate of change is $11.5 per hour, which sounds a little awkward. So what I mean by that is, if you're looking at it from a contextual perspective, the rate of pay is $11.50 per hour. And for every hour worked, I earned $11.50. So now we have the number value for the constant rate of change, but we also know its units. It's measured in dollars per hour. So let's see what we can learn from this. So, how much more or less will I make if I work 4 more hours or 4 less hours? And we're going to use this idea of, now that we know something about the constant rate of change, answer these questions. Again, we'll use that constant multiple perspective proportionality because it's super helpful to answer these questions. So we know that the change in H is going to be 4 for part A, because it's 4 more hours. And so this means the change in D is equal to some constant rate of change times delta H, which in this case means the change in D is 11.5 times 4, which gives us 46 for a change in the amount of dollars I made. That means I made $46 more from whatever I did before. Let's now also look at part B. If I'm working 4 less hours, that means my change in number of hours worked is a change of negative 4. Putting it into that formula, change in dollars is equal to the constant rate of change times the change in hours. And so the change in dollars is equal to 11.5 times negative 4, which means my change in dollars, or change in D in this case, is negative 46. And again, I'm using that delta notation to represent change. So this would mean that I made $46 less. Of course, the question you may be asking, relative to what? Doesn't matter. And so what I'm going to do is I'm going to pick one of the 2 points, either 12,188 or the 26,349 as a way just to measure relatively what that means. I'm going to choose 26,349. Now let's look at it visually. Let's first look at part A. So over here, I changed, but my hours changed, was 4 hours additional, and I made $46 more. So if I add 4 to my hours, it's 30. And if I add 46 to the amount of money I made, that would tell us that I made $395. So 30, 395 would represent the coordinate representing how much I made in 30 for working 30 hours. For 30 hours worked, I'd make 395. That's using that idea of change. You can actually make predictions about the actual hours and dollars made. It doesn't matter where you take it relative to. Let's also look at B. We'll again start at 26,349 and see what would happen if we worked 4 less hours than 26 hours. So it says, so working 4 less hours means my change in hours worked is negative 4. And that means I made 46 less, so that means my change in dollars is negative 46. If I do a little bit of math, that would mean that I worked 22 hours, and if I subtract $46 from the $349 I made, I have now made $303. So the ordered pair that represents this relationship is that 22, 303, which means that if I work 22 hours, I made $303. Let's look at some other questions as well. Suppose the question is, how much more or less will I make if I work 10 less hours and 2 less hours? Now this is a process, again, that we're going to use the same approach using that constant multiple perspective proportionality. So again, delta H in this case is negative 10. We'll use the same formula, which is delta D is equal to the constant rate change times delta H. Delta D is equal to 11.5 times negative 10. And lastly, delta D is equal to negative 115 when we calculate that multiplication question. So this would say that if I work 10 less hours, I would make $115 less. So now look at the 2 less hours scenario, which is part D. So that would tell us that the change in H is negative 2. That would mean that the change in D is equal to the constant rate of change times delta H. That would tell us that the delta D is equal to 11.5 times negative 2. And so, doing a little math, delta D is equal to negative 23. So that would tell us that if I work 2 less hours, I make $23 less. And now again, it does not matter relative. I could take any of these points and it would give me a correct calculation. So let's explore first what it would mean to work 10 less hours in relation to salary. So in this case, if I work 10 hours less from, let's say I chose my 12,188. So if I work 10 hours less than 12, that would mean that I make $115 less. So working 10 less than 12 would mean I work 2 hours, and making 115 less than 188 means I made $73. So the coordinate that goes with the point that you see here is 2, 73. If I work 2 hours, I made $73. Now that you might start thinking about what that might mean, we'll come back to this point shortly. But let's say, again, it doesn't really matter where I took it from. So let's say I started from 22 hours and $303. Okay, so I'm going to go through the same process again. If I work $10 hours less, delta H is equal to negative 10. And that corresponds to delta D of negative 115, which would mean that for, again, working 10 less hours means I make 115 less. Now let's see if this works, because what it looks like is it matches up on the point 12, 188. So if I take 10 hours less than 22, that is 12. And if I go $115 less than 303, that really does match up with 188. So what's nice to know about this is that having this constant rate of change does produce consistent answers. In other words, there's no contradiction of the money I make when it's related by the constant rate of change. You end up with results that are consistent. Now you might have looked at this 2,73, which is right over here. You might be thinking, well, wait, what does that mean? Because if I were just making a rough estimate, that would make me seem like I'm making more than $35 an hour. But according to this, I'm making $11.50 an hour, so something else must be happening. So perhaps using this 2 less hours may help me make sense of this situation. So if I work 2 hours less, I make $23 less. So let's explore what that means. I'm going to make a change of 2 hours less than 2. So that puts me at 0. And then I'm also going to make 23 less than $73. So that would mean that I would actually have 0.50 as my ordered pair. So that would tell me that if I work no hours, I made $50. Now there are situations in employment where they will give you a base pay, and then for any additional hours you work, you get paid additional money. And it appears that in this particular situation, that is exactly what's happening. You do get $50 for showing up, so it might be in the case where you are making sales, and so you get a base pay plus a rate for working on the floor. Or it might be a case where you need to bring supplies and the employer is giving you money for your supplies for showing up, and then you use your supplies while you are doing your work. So there's some situations where this makes perfect sense. Now it looks very interesting is that you might notice that it would appear that the dots are in a very particular configuration. So we're going to explore that very soon. There's one other question we can take a look at, which is, let's look at it in relation to money. How many more or less hours did I work if my pay changed by 230? That's for part E. And for part F, negative 86.25. We're going to use the same strategy, but notice now we're talking about the change in money and not the change in time. So again, delta D is equal to the constant rate of change times delta H for part E. In this case, we're using delta D. That's something we do know. So delta D is 230 because I made $230 more. And that is 11.5 times delta H. So doing a little bit of arithmetic, we end up with delta H is equal to 20. We use the same process for F. But what this means is that I worked, before I get to F, this means that I worked 20 more hours. Now let's look at F. Same start. Delta D is equal to the constant rate change times delta H. This would mean that negative 86.25 is equal to 11.5 times delta H. And so doing some math, and I mean doing some math on a calculator, or you can do log division, but if you have a calculator, definitely use it. It would say, this would mean that delta H is equal to negative 7.5. So doing that, that would imply that I worked 7.5 less hours. Now when we're looking at this graph here, let's see if this actually could work. So I do notice that the 273 and the 303 are 20 hours apart. So let's actually verify this work. Imagine I start working 303, this is 303, and I made 230 less in pay. So if I take 303 and I subtract 230, that would put me somewhere around here. And that corresponding change in hours would be a change in negative 20, which would put me in 273. If I take 303 and I subtract 230, I do get 73. And if I take 22 and I subtract 20, because I worked 20 less hours, I would be at 2 hours. So this is consistent. And again, I did choose 2 points would happen to be on the graph, but this would be true from any point you take it from. Clearly, you would not take it from 12 because that would make us negative hours, and that would be outside the domain of this function. It only makes sense to work 0 hours or more. What I mean by 0 hours or more, 0 hours means you show up, and then you continue working consistently for the number of hours you're employed for that week. Let's continue on. So what does it mean to be a linear function? Well, we would define a function or a relationship between quantities to be linear if the quantities are related by a constant rate of change. In this situation, we had quantities that were related by a constant rate of change. And it definitely appears that there's something that might be linear about it. So let's see what that means. If a function is continuous, the resulting graph of the quantities related by a constant rate of change will always be a line. If the function is discrete and the quantities are related by a constant rate of change, a line can always be drawn through all the points of the associated graph. Now in this situation, what we don't know is what is the employer's policy. Do they pay you for any amount of time you work, which would mean that the time is measured, and that would be a continuous function. So that means that all dots are possible, and that these just only represent a few dots taken from the perspective of the situation. Or perhaps the function is discrete. In other words, maybe you only are paid at the hour mark, or maybe at the half-hour mark, which would mean that the amount of time you worked actually would be counted. Regardless of this situation, according to this, we should have a linear function, meaning that we can't draw a line through the points. So let's find out if that's the case. We're going to draw a line and see what happens. Notice that a line fits through all the points. So if it's a discrete situation, that means if you have a bunch of dots that represent all the possible hours that you are really paid for, the line would go through all these dots. If it is a continuous function where you're paid for any amount of time you worked, then any point that's along this line would be a valid possibility of hours and money earned. In summary, $11.50 per hour was the constant rate of change of the amount of money earned with respect to time in this context. We did find that the $11.50 per hour was the constant rate of change, but you might be wondering what the word respect to means. With respect to in math is a very special relationship between two quantities. And what it is the amount the word that is used before with respect to the quantity referred to with respect to before the amount of money earned refers to the output. So the words that come before respect to refers to the quantity, that is, the output. The quantity that comes after the word respect to is always going to be the input. In this case, the input is time. And when you look at this, the number of hours worked refers to the time, which is the input. The amount of money made in dollars is the output. So this is consistent with that verbiage. So when you see respect to math, whatever quantity is referred to before the respect to is going to be your output, and whatever quantity that comes after the word with respect to is the input. And that's why you'll see the amount of money with respect to time in this context. So I hope you found this lesson helpful.